Okay, today we are jumping to 5.5. 5.3 and 5.4 are in this forum impossible to deal with. I did try to make a video for 5.3, and the level of confusion that it will cause is it's just not worth it. So we are jumping to 5.5, which finishes this chapter for us. Okay, so the first thing that we're going to be studying is a corollary to the triangle exterior angle theorem. Now that corollary says on page 290, the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. Okay, so if you recall from the triangle exterior angle theorem, it said that the exterior angle is equal to the sum of its remote interiors. Okay, so the theorem, and I'm going to change color so you can kind of follow. The theorem said that angle 1 is equal to angle 2 plus angle 3. That's the theorem. That was an equality theorem. The corollary to that is an inequality theorem. So, again, the measure of an exterior angle of a triangle is greater than the measure of each, not the sum, is greater than the measure of each of its remote interiors. So angle 1 is our exterior angle, and it is greater than the measure of angle 2, and it is also greater than the measure of angle 3. Okay? Okay. Now we're looking at theorem 510, which is somewhat down towards the middle of that page. It says, cut and dry basically, the largest angle in a triangle, as long as the angles are not congruent, the largest angle is opposite the longest side. Likewise, in theorem 511, the longest side is opposite the largest angle. And again, that's assuming that none of the angles have the same measure. Okay, so when we look at this triangle right here, we can identify the longest side by locating the largest angle and going opposite from that. So the longest side, BC, that is the longest side because it's opposite. Oh my gosh, no, it's not. Actually, largest angle, hello, 92. You guys are wondering, what the heck is that crazy person talking about? Okay, the longest side then would be AB. I even drew this thing and I didn't even see the 92. Okay, the longest side is AB because it is across from the largest angle. Likewise, the largest angle here in this drawing is going to be across from the longest side. Well, obviously, AB is the longest side of that triangle, so the angle opposite that would be angle C. Very, very simple concept. Okay, now this is the one that we're going to spend the most time on. The triangle inequality theorem. That's your theorem 512. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So here what we're going to do is draw this triangle, and we're going to see if in fact those side lengths would create a triangle, because it just might be that one of the sides is just a little too short. Say that's the side length 7, 9, and that's 2. It very well might be the case that the side length of 2 there is just not long enough to close up the triangle. Okay, so this is what the triangle inequality theorem tells us. Can the three sides given even form a triangle? Okay, so we're going to study that theorem and label, so obviously not to scale. we'll put the 2 there, the 9 here, and the 7 here, okay? The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So I'm going to pick my anchor point right there and start with the side measure of 2 and go this way around the triangle. So what that theorem says is 2 plus 7 has to be greater than 9. Then 7 plus 9 has to be greater than 2. And then 9 plus 2 has to be greater than 7. Okay, well, if you look at this first statement here, 9 is not greater than 9. So what that means is that is not the side, those cannot be the side lengths of a triangle because 9 is not greater than 9. Okay, so let's look at B. Okay, and again, very not drawn to scale. So let's do, there would be 4, there would be 6, and that would be 9. Okay, that's about the best I can do. All right, so the triangle inequality theorem, I'm going to start with 4 and go this way. 4 plus 6 has to be greater than 9, which is the third side. Then 6 plus 9 has to be greater than 4. And then 9 plus 4 has to be greater than 6. So 10 is greater than 9. 15 is greater than 4. And 13 is greater than 6. So yes, this is a triangle when you use those sides, okay? Whereas in the example A, with 9 not being greater than 9, that is not the side lengths. Those are not the side lengths that will create an actual triangle, okay? 2 is just too short. If it was a little bit longer, 2 is too short. So if that 2 was, say, even a 3 or a 4 or a 5, then that would be greater than 9. But the side length of 2 is just too short to close the triangle. So what it would look like, it would be something like this, okay? It's just not long enough, okay? Now we're kind of flipping this theorem and working backwards with it. So instead of being given sides that we have to determine whether or not they actually make up a triangle, we're going to use the triangle inequality theorem to find the possible lengths of the third side, okay? So we're going to draw the triangle. There would be a 3, there would be about a 12, and this third side is the side in question, okay? What are the possible lengths of that third side? So we've got 3, 12, and we will just call that X. So we'll start with the 3 and go clockwise. So 3 plus 12 has to be greater than X. 12 plus X has to be greater than 3. And X plus 3 has to be greater than 12. And we're going to solve each one of these inequalities, okay? Starting at the top, 3 plus 12 is greater than X, tells us that 15 is greater than X, which is the same thing as saying X is less than 15, okay? Then we'll solve the second inequality for X, and we'd subtract 12 from both sides to give us that X is greater than negative 9. Well, that is not going to work because the two things in math that will never be negative are distances and time. And the length of a side is a distance, so it cannot be negative. So solving the last inequality, we'll subtract 3 from both sides, and we get that X is greater than 9. So as long as X is greater than 9 and less than 15, those sides then will form a triangle. Okay, so this is another example of that. we'll draw the triangle. Okay, and then we'll just call this side X. So 4, 7, and a missing third side length there. Okay, so starting at the 4, 4 plus 7 has to be greater than X. 7 plus X has to be greater than 4. And X plus 4 has to be greater than 7. So the first inequality tells us that X has to be less than 11. Okay? The middle inequality here says that X has to be greater than -3. That is our, we get to throw that one away right away. Discount that, doesn't make sense. Likewise, the third inequality there says that X has to be greater than 3. So as long as X is greater than 3 and less than 11, those side lengths would form a triangle. Okay? Very, very simple. Okay, that's it. And then we will finish the chapter.